All right, this is the concept builder for parallel circuits. And today I'm actually going to have you skip the apprentice level because it's the same as the last one. I'm going to have you go to master level and I'm going to do this with you. So here you have a simple parallel circuit, two resistors, and a bunch of different places on the circuit. The battery voltage here is 6 volts, and resistor 1 is 3 ohms, resistor 2 is 2 ohms, and you got 5 amps of current at point A that's coming out of the battery. Okay, so to find the current going through point B, all you got to do is take the voltage divided by this resistance. So it's 6 divided by 3, it should be 2 amps of current. Over here, the resistor is only 2 ohms, so you take that same voltage, 6 divided by 2, and you should get 3 amps of current. Okay? Now you're looking at the same circuit, but it's got a 12 volt battery. The resistors are still 3 and 2. Now current coming out of the battery is 10. So what you got to do for current at B, which is the first branch, you take the voltage divided by the resistor. So 12 divided by 3 is going to give you 4. Over here, you're taking 12 divided by 2. Resistor 2 is 2 ohms. 12 divided by 2 is 6. Now I want to point out, in both of these first rows, current A, which is the total, has to add up to each of these two added together. So 2 plus 3 is 5, and 4 plus 6 is 10. Now current at D is just going to be the same as current at A because whatever comes out of the battery has to go back in. Over here you've got 12 volt battery, 6 ohm resistor, and 3 ohm resistor, and it wants to know the total current coming out. Well, this is a little bit tricky because first you've got to find the total resistance. Use the formula for finding resistance of a circuit for parallel circuits, you end up with a total resistance of 2 ohms. You're going to have to do that on your own calculator since I cannot exit the screen to show you that. Actually, sorry, I'm making a mistake here. 2 ohms is the total resistance, but this is the total current. So what you have to do is take 12 volts divided by 2 ohms, which would give you a total resistance, total current coming out of the battery of 6 amps. Sorry, so total resistance is 2. 12 divided by the total resistance gives you current A, which is 6. Okay, so now we can go back to the current through each branch. So the current at B is just 12 divided by 6, which is 2. The current going through resistor 2 is 12 divided by 3, which is 4. And once again, those two add up to give you 6. The current at D is going to be just the same as the current at A. This next row is the same. You have to find the total resistance. And again, if you do that, you're going to get a value of 2.666 repeating ohms. So it's like 2 2/3 of an ohm. When you take the total voltage, 24, divided by that total resistance of 2.6 repeating, you get a current coming out of the battery of 9 amps. Now you can look at the current at B and C. So 24 divided by resistor 1, 24 divided by 4 is 6. That's how much current is going through B. And 24 divided by 8 is 3. That's how much current is going through resistor 2, point C. And again, going back into the battery, you still have 9 amps. Okay, so now they're giving you the current at C. So this is kind of a puzzle. You got to work backwards. If the current going through C is 5 amps and resistor 2 is left blank, that doesn't really leave us much to go on. So let's start with what we can do. If you take the voltage divided by resistor 1, you can figure out the current going through branch B. So 30 divided by 5 is going to give you 6. Well, now you know that these two currents added together, 6 and 5, are going to give you 11 and 11. Okay, so now we can work backwards to get the total resistance. 30 divided by the total current will give you the total resistance, and then you can find R2. Okay, and if you work backwards using the parallel resistor formula, you end up getting a resistor here for R2 of 6 ohms. So let's check our work. I was actually worried some of those were going to be wrong. These are a little trickier. Okay, good luck with yours now. Have a good day.